Yeah, okay. It's a coin. Thank you. It's not a rock, it's a coin. Okay, so if you drop the coin and the feather, and because there is air resistance, not only gravitational pull, napay air resistance nga mag-oppose, which is upward ang air resistance, and ang gravity is downward. So it's not solely with the acceleration due to gravity. It's also with the air resistance. So mo nang because of the surface of the feather, the cushion surface, and it's their light, so naay greater effect ang air resistance niya. So there is a air resistance greater effect such that ang coin mo tagak first. Okay, mo mahulog first. And in vacuum, kung walay air na vacuum, so meaning zero air, so they will fall to the ground or to the bottom at the same time. So that is free fall. Walay air resistance. Pero kung na air resistance, mo nang imong i-account nga na upward force. Okay? Aside from the downward force that will give you the downward acceleration. So in vacuum, magdungan gyud siya og tagak ang feather and coin or an apple and feather. Okay, so we will use this 9.80 meter per second squared as the value of g. So it's an application of constant acceleration. And take note, since it is downward, we will affix a negative sign in our equations later. Okay, di ba? Naman tayo V naught plus AT. So may mo siyang V naught minus GT. Nganong minus man? The minus there is the sign, the direction of the acceleration due to gravity, 9.80. And in British system, it's 32.2 feet per second squared. But more or less, we'll be using 9.80 in our case in physics. So these are the equations now. Remember, we derived this equation. V equals V naught plus AT, the constant acceleration, the blue one. Have you noticed this one? So kini nag-derive ta ani previously, and this is just the definition of acceleration, the change in velocity over time. Okay? Wherein time zero is zero. So mo nang t final na nabilin, the time interval. So in this case, if we will convert it to a free fall equation, we will change the a to g because the acceleration now here is acceleration due to gravity, and we will change the plus to minus because of the direction nga downward. So whatever nga imong i-plug in nga value here, it's not negative 9.8 but 9.8. Why 9.8? Because the negative is explicitly expressed in the equation. But in some other books, kung maglibog mo, nagamit sila plus GT here. If plus GT ang ibutang diri sa ubang books, ang imong ibutang nga G nga value is negative 9.80. Okay? Naka-follow? So in our equation, be resilient lang ha, be flexible. If you are given an equation or you are familiar with the equation, V is the final velocity, V naught is initial minus GT. If there is minus there, it indicates that the acceleration due to gravity na downward is explicitly expressed in the equation. So the value of your G will be 9.80. But if your equation is V naught plus GT, you substitute negative 9.80 because that is for downward. Okay? Follow so far? Okay, so sa ubang books, plus na. So imong ibutang negative 9.80. Sa kini nga reference, minus na. So imong ibutang positive 9.80. But in other words, ma-negative ra siya because of acceleration due to gravity. And another constant acceleration, if we want to have the displacement also, and involving time and acceleration and the initial velocity is this. X is equal to x naught. Diba? Diri man ta na x minus x naught. Or you can transpose x naught on the other side. X equal to x naught plus v naught t plus 1 half a t squared. Constant acceleration. So you change a to g. And of course, a g now is negative because it's downward. And the sign here will become minus. Okay, so still what you will give there for G is the positive 9.80 because the minus is explicitly put in the equation, is expressed in the equation. Also, in the last equation that you have to remember, if you want to solve for the final velocity, v squared is equal to v naught squared plus 2ax, and then in parentheses x minus x naught, which is the displacement. So the G here, the A here can be replaced with a G, and of course the sign will become minus. Okay, because the acceleration due to gravity is downward. Okay, so these are the three equations. So morning, I said I just focus on the free fall because this is just the application of constant acceleration. So kung na problem nga not free fall like car, so you just use these equations. Kining na 80 general equation. But if you want to apply it in free fall or objects falling to the earth, you use this equation wherein A has been replaced with G. Okay? Any questions so far with the equations? And as you have noticed, it involves quadratic equation. There's t squared. Okay? Sa math man kod kay x ra og y. Sa physics kay nanay x naught, so nanay subscript. Pero ayaw mo ka-intimidate. They are just variables. So x naught could be just y. Yeah, so kana lang. V naught is initial velocity and time. So here it's quadratic equation. Familiar with quadratic equation? Quadratic equation. Okay, so familiar na tanan. And here v squared, so it's also quadratic equation also. So simple kung quadratic equation in math. So let's deal with problems. Okay, so mo man importante sa physics makamaot og problem sa pag-apply. So this one, a boy on a bridge throws a stone vertically downward. So in this case, you be alert with the term downward, upward because it will give you a sign. Kung downward, that's negative. Okay? With an initial speed of 14.7 meter per second toward a river below. If the stone hits the water 2.00 seconds later, what is the height of the bridge above the water? So you are asked about the height of the bridge and you're given the following quantity. So this is a free fall problem. Kay neglecting air resistance kung wala gibutang that, this is a free fall. So which is taken as the negative direction ang velocity downward, so negative na siya. And this factor is explicitly expressed. So the draw sketch, so you can draw a sketch for that. So as usual, first writing what is given and what is to be found. So sa problem solving, aron na mo'y masuwat or na mo'y ma-analyze, first given. So given, V naught is negative 14.7 meter per second. Why negative? Because it is anong negative gani?
Downward.
Downward. Very good.
Downward.
And time is 2 seconds. Okay? And G is not given, but since it is a free fall, kay nag-throw man ka, it's understood nga imong G is 9.80 meter per second squared, which is the acceleration. And you are asked about the Y, the bridge height. Okay, so notice that G is listed as a positive number since by our convention, the directional minus sign has already been put into the previous equation of motion. That's what I told you. We explicitly express the negative sign in the equation. So we can use this equation. Y equals, ang Y naught na wala because we can take Y naught as 0. So katong gikanan niya, Y naught is 0. So Y ra ato the whole Y. Okay? Di ba gi-throw down man niya. So from the bridge niya, y ni siya pa down. So you're expecting a negative answer kay pa down man siya, the final man na displacement. And y naught is there there. So y is equal to v naught t minus 1/2 gt squared. So v naught is negative 14.7, time is 2 seconds minus 1/2, and then g is 9.80 meter per second squared, 2 seconds squared. You cancel the units, second canceled, second squared canceled, and take note what I told you na you cannot add quantities having different units. So V naught T will give you meter, 1/2 GT squared will give you meter as based on the cancellation. So negative 29.4 minus 9.6, 19.6, you will get negative 49.0 meter. So the minus sign indicates the rack's displacement is downward as it should be. Okay? So mo na significance sa minus. Thus the height of the bridge, kay height is just a scalar quantity raman, is 49.0 meters. Any question about this problem? Clear? Clear lang? You have to remember lang that G is 9.80. And if your equation is you are using minus, you just have it positive 9.80. Okay? So, ay mo timan-an, katong tulo ka equation, magpili mo ato asay pabor ani nga equation based on the given. So, based on the given, na kay V naught, na kay T, na kay G. So, you can use that equation. Rather than you use V squared equals V naught squared minus 2AY minus Y naught because the X there could be Y. And take note, taghang kag mga unknown, wa kay V squared, wa kay, na kay V naught, pero wa kay final velocity. So, mamili ka tong tulo ka equation nga akong gi-flash. So that's how to have the problem. That's why it's important to have the given. So in cases nga magpahatag ko og problem, magbutang mo given. Okay? So later magbutang ko mga problem. Okay, this is another application, reaction time. Reaction time is the time nga makareact ka for a given stimulus. So it's important like for drivers, kung mag-drive ka, yan ay mulabang kalit, and mo step ka on the brake, so it needs a certain reaction time. Dili na siya automatic nga makareact din ka because our brain needs to process. So how to measure the reaction time? It's an application of free fall. A person's reaction time can be measured by having another person drop a ruler without warning, even with and through the first person's thumb and forefinger. So this is shown. Ang babay nagdrop siya og ruler, ang laki may mukatch. So sa end sa ruler nagandam ang guy to catch the ruler. So after observing the unexpected release, the first person grasp the without warning ang girl mo drop siya sa ruler. So as a reaction, the guy will try to catch it with a finger. So since there is a measurement, ma-measure pila ang iyang na-catch, pila ang height sa iyang na-catch. So there, suppose the ruler descends 18.0 centimeters before it is caught. So naka-descend siya 18.0 cm. What is the person's reaction time? So kining second figure mao na ni nga na-catch na sa guy 18.0 cm. So how to do that? Duharay give o saray given 18.0 cm. Unsa man ang 18.0 cm be? It's the y. Sakto? Okay, starting with y not 0. So naanaw siya, it's the y. So there, you can have y is negative 18.0 cm or 8. You convert to SI unit. Take note, ang SI meters gamiton, second ang time. So negative 18, negative 0.180 meters. So you find the reaction time. So since you want to find the reaction time, so it's the second. So V note there is 0 because it's dropped. Take note in a problem, if the object is being dropped, the initial velocity is 0. And of course, though it is not given in the problem, take note, if it is a free fall, you just have to use the g, which is 9.80 meter per second squared. So from among the equation, unsa may magamit nga equation? So you can have y equals y naught plus v naught t, but y naught is 0 and v naught is 0. So mahabilin is 1 half negative 1 half gt squared. Nakuha sa equation, nganong negative 1 half gt squared na bilin? Y naught is 0, the initial, then naman ay y naught ta dire. Then plus v naught t because it's drop. Take note of the word drop. Kung gi-drop ra, wala siya initial velocity. If gi-thrown downward, na siya initial velocity. So it's drop man. So v naught is 0. So mahabilin is negative 1 half gt squared. So we have to solve for the time and reaction time. So how? Of course, may muning 2y over g and then it's negative. Yeah, take note, ang y pod kay negative man na kay pa downward man tong y. So and you get the square root kay t squared man. It's a quadratic equation, di ba? So there are two values of time. So in that case, square root of 2y over negative g. So take note, there is a negative in the numerator and negative in the denominator, so you'll end up with a positive sign. Otherwise, you will have an imaginary number. So your reaction time of the reaction time of the guy is 0.192 seconds. Okay? So that is how to measure the reaction time. You can try it yourself there at home and give me your reaction time. Pila yung reaction time. Inyo harang i-compute using this formula. T is equal to square root of 2y over negative g. Oh, so you try and you send me a message pila yung reaction time. Yeah, later na lang. You try this experiment. Okay ra, nasabtan eh. Nasabtan ra? Okay. Si Layray ako makitaan. Ang uban wala dyan nag-turn on sa camera. So, yeah, so
Sorry sir.
oh, yes, Mishka og si Andre. Sila ra lagi tulong. What's wrong with your faces di ay? Dili mo ganahan.
Afraid, sir.
They're afraid. Oh. Okay, so there. We have that second problem. And third problem is throwing up. Yeah, going down. So medyo complicated din isa. And you have to take note kung upward, positive, downward is negative. And also, the title is using implicit data. When you say implicit, it's not given in the problem, but it's assumed that you know it, like the acceleration due to gravity, which is 9.80 meter per second squared. So this problem, a worker on a scaffold in front of a billboard throws a ball straight up. So it's thrown straight up, meaning the initial velocity is positive. Okay, the ball has initial speed of 11.2 meter per second when it leaves the worker's hand at the top of the billboard. So what is the maximum height the ball reaches relative to the top of the billboard? So the maximum height, take note, a maximum height mo na turning point. So when you say turning point, diha siya mo change of direction ang object. So in that case, it momentarily stops there at the maximum height. So implicit data is at the maximum height, the velocity of that ball is 0. Okay, at the maximum height. And then how long does it take the ball to reach this height? And what is the position of the ball at t is equal to 2.00 seconds. So there are three quantities to be solved. So thinking it through, in part A, only the upward part of the motion has to be considered. So positive velocity upward. And note that the ball stops, zero instantaneous velocity at the maximum height. So you can have that at the top of its height, the final velocity is zero. And then in part B, knowing the maximum height allows the determination of the upward time of flight. And in part C, the distance time equation applies for any time and therefore allows calculation of the position of the ball relative to the launch point at 2.00 seconds. So kung makaibaw na ka sa maximum height, makakabaw na ka sa upward time sa part B. Yang part C, na kay distance time equation, katong na y and it, katong 1 half gt squared, na kay apply that one and you can calculate the y position relative to the launch point. Take note, gi-launch ang ball, y is equal to 0 here at the top of the billboard. Ka-level siyang hand. Okay, gi-throw niya up. So, in that case, this y naught is equal to 0. Nakita ang drawing? Yeah, ang top sa height sa ball is y is equal to y max. And v final at the maximum height is 0. And take note, g sa ball, parihara tanan. Ang acceleration due to gravity, it is the common misconception, dili na mausab. Bisan na ang velocity 0 at the maximum height, take note of this, g gihapon na. Nagyapon yung acceleration due to gravity nga downward nga negative. Mao gani ang bola, mahitabuan na is ang velocity, kung i-throw up nimo, ang velocity sa bola, ang tanawan ng green arrow nga padung up. Di ba nagkagamay? Ngano nagkagamay ang green arrow? Because acceleration due to gravity is downward. So nagkahinay ang ball until mo stop. And then, take note that the G here vector, kining arrow sa G parihara. It never changes all throughout, basta free fall. Dili mausab ang G, but ang velocity mausab until ma-zero. Bisan zero yung velocity, wala na zero acceleration. Kay naaman ng Earth. Wala man mo gipawong ang Earth. Nara magina ang Earth nag-act. So naara GG nga kuan niya. So mga concept nga question ako sa quiz, what is the acceleration due to gravity at the maximum height? So mingon mo zero. No, it's not zero. It's still G. The acceleration due to gravity. Ang zero diha is ang velocity lang. Kaya nagkaanam siya kahinay. Yeah, after the maximum height, magkaanam siya kakusog. Tanawa na sa ning green arrow. So kung i-compare nimo nga same siya position, parihara silang magnitude pero opposite in direction. Mo ni na quadratic ang equation, di ba? Natoy v squared kay same siya velocity o time sad kay same time at the same height. So there, mo tong na kay t squared sa equation up kay v squared sa equation. So kay na pa up, na pa down, pareha na silang magnitude. Ang usa positive, ang usa negative. Okay? So this is how the situation looks like. And how to solve for that? So what is the maximum height the ball reaches relative to the top of the billboard? So y max. Gamit na kag equation. So use the given. So v naught is 11.2 meter per second. Pa-up is positive. Implicit data is acceleration due to gravity 9.80. And v is equal to 0 at the maximum height. It's an implicit data also. And t is 2 seconds at later time. Okay, so notice that the height y naught is equal to 0 is reference to the top of the billboard. So katong billboard pa pag-release niya. So dito ang y is equal to y naught is equal to 0. So gamito ni mga equation para makasolve ka sa y max. So gamit ka atong equation nga mag-relate sa velocity and the y. So in that case, you have, if you remember the equation, v squared equals v naught squared minus 2gy. Y is just y minus y naught, or y naught is 0. So nahimo ng y max there. So in that case, your v squared is 0 and v naught squared is known, okay, based on this equation. I will annotate so that you can follow. Okay. So, take note this equation here na 0 ang v squared. Okay? And habilin is v naught squared minus 2gy max. Wala na y naught diri minus y naught munta ni diri in parentheses because this is 0. So, there, you can solve for the y max here. You can, because it's 0 here, you solve for y max and it's equal to v naught squared over 2g. Okay? Just algebra. Yeah, it's chicken feed. It's algebra lang. 11.2 meter per second squared divided by 2 times 9.80 meter per second squared. And of course, you can cancel out units. So you're expected to have meters because you're asked about the maximum height. And it's 6.40 meters. Okay, so the height relative to the top of the billboard is 6.40 meters. And if you're asked about the time the ball reaches its maximum height, so just a simple equation, the v equal v naught plus 80. And you know v, kaning final velocity, the maximum height is 0. So kini na 0 na siya. So mabili ng equation. V naught minus T GTU. Meaning time to go up. Kaya na pa may time to go down. So you can just have subscript sa imong equation aron di ka maglibog. So TU there means time to go up. So to solve for time to go up, algebraically, it will be V naught over G. And you know V naught, the pag-throw nimo, 11.2 divided by 89.80 meter per second squared. You cancel meter, and then may mabiling nga second. So your time to go up is 1.14 seconds. Okay? So naka-follow so far? Okay, thanks, Lay. Andre. Okay ra? Ka-follow ra? Okay, so just use the equation. And of course, you base it on the given. So the third one, ang third is find out the y at t is called 2 seconds. So take note, pag 1.14 seconds na siya dito sa top, time to reach maximum height. Kung mangutana siya ang question, what's the height at 2 seconds? So asa na dapit ang bola day? Is it going up or pa down na siya? Kung 2 seconds na ang gipangutana. So time to go up until maximum height is 1.14 seconds. And then it's asking unsa iyang height at 2 seconds. Why? So asa na dapit ang ball? Is it going up or going down? Going down. Okay, going down na siya. But nana diri ang bola, pero naabot na siya sa y is equal to 0, wala pa no, di ba? Padong pa man siya kay 1 kay time to go up is 1.14 seconds. So since it's quadratic, time to go down sa same height is 1.14 also. Mo na shortcut. Kay quadratic man siya. Time to go up 1.14. Time to go down same height nga iyang gi-release point is 1.14 as well. So kung 2 seconds, meaning nasa tunga-tunga, padong na siya sa y is equal to 0. Okay? There. So in this case, you use this equation based sa tulo ka equation, you may evaluate as ay magamit. So V naught T minus 1 half GT squared. So 11.2 meter per second times 2 seconds. Kay mamanay mo ang initial velocity up man to positive. 2 seconds ang time minus 1 half 9.80. 2 seconds kapon gi-square. So makuha kag 2.8 meters. Question, nganong positive man siya gihapon? Nganong di man negative? Because it is the displacement. Di ba ang displacement is initial minus final? Ang initial na aman dire. Na dire ang initial. Ya, dito siya padong ya dire. So final wala pa siya kaabot, di ba? Final minus initial, so still positive because it's still above 0, above the y is equal to 0. So that's why 2.8 meters. So there's another approach in solving this problem. So considered from another reference point, the situation in part C can be analyzed by imagining dropping a ball. So pwede po mag-analyze mo dito nagikan sa maximum height. Nag-drop na ka, dropping na. Kung dropping, V naught is 0. Kay ganina, atong gigamit is gikan kita sa release point nga positive velocity. Pwede man sa nimo i-analyze gikan sa maximum height kay mura siya gi-drop para kay final velocity at the maximum height is 0 man. So there, you can use that. V naught is equal to 0 and asking how far it falls in 2 seconds. I-minusan lang nimo sa time to go up. Kay time to go up is 1.14 man. So giminusan nimong 2 seconds minus time to go up nga 1.14 seconds. So 0.86. So meaning 0.86 pag go down. Kay pag go up 1.14. Ya 2 man. So minusan nimo 1.14 aron dito nimo ilabot kay nag-analyze man ka nga gikan ka sa taas. So therefore, 0.86 seconds na siya pa down and you will use V initially 0. So minus 1 half GT squared. So ay mo makuha is negative 3.6 meters. And take note, ganina nakakuha tag 6.4 meters pag go up. Aron makuha kag 6.4 meters, 3.6 pag go down, so i-minus lang nato. So that is 2.8 meters above the starting point. It will give you the same answer. Okay? So parihara siya answer. So this is free fall application. Any question? Nalapas na tag 17 minutes, but anyway, this is the last problem. Walay question? Okay ra, na yung mga inaning problem sa quiz. But it will be multiple choice. Okay? Later on Wednesday, 3 p.m. Okay ra? Wednesday. Okay ra, Andre? Karong Wednesday? About this test? Lay, okay ra? Okay ra? How about the others with no camera? Any problem? Okay ra?
Okay
Yeah.
ra, sir.
Yeah, speak up please. Unsa may concern so far? Nakuha ra ni? I
Yes, sir.
Okay, thank you. So I'll stop sharing and I post this discussion on YouTube or hindi na ako mag-prepare lain. Aron gamay ra siya. Okay, so that's it. Uh, and next meeting is vectors. Naman mo nila kog post aron di kay mo overwhelm. Unahon ako ang perusal aron magbasa lang sa mo. Aron friendly ra kay I can relate to you na daghan kay mo og gipang buhat sa ubang subjects like in 1 week na mo'y tulo ka i-submit. That's why I'm not strict with the submission. You can still submit sa katong mga navigate nga part even until next week kung di jud makaya. Okay? We will extend our patience in this case. So basta mo perform lang mo sa quiz, magtuon, so mao na ako quiz aron di sad mo kumpiyansa, magbasa sad mo magtuon. So I'll be posting perusal first before the lesson guides. I know mag-compare mo sa ubang sections, please it's adjustment na ay uban sigurong mga campuses nga nag-una and then dili mo matter kayo ang paspason basta makakaton lang. Okay? Nga kay it's difficult on your part also nga walay discussion good. Okay? So nay pangutana. It's time to air out some concerns. Tawagon we. Jody Isobel. Jody?
Yes,
Nay
sir.
nay concerns?
None, sir.
Okay ra?
Yes, sir.
Okay, Roland, Racoma?
Sir, for perusal, sir, kailangan mag-annotate, sir.
Ay, Jen. Okay. Yeah, minimal annotation lang. Pwede 5 lang. Ano man? Why Jen? You don't like annotation?
Okay ra, sir. Okay ra, sir.
Okay ra, okay. Aron magbasa lang mupod mo ba, murag two birds in one stone, magraduhan mo in the perusal annotation, but please write in English, ha? Okay. There about the topic vectors. But anyway, mag-quiz ta Wednesday paman on free fall and constant acceleration. So kung constant acceleration nga problem, A rin yung gamiton. Yeah, whatever the acceleration value. Basta remember lang, kung opposite ang acceleration of velocity, magkahina yung object. Okay, then like that. Kung turning point, velocity at that turning point is 0 instantaneously. Okay, napay concern, Russell. Russell? Rans.
None, sir.
Okay, Nan? Rans?
None, sir.
Okay. Bernard?
None, sir.
Okay. Ville?
None, sir.
Okay. Mark? Luis? Mark Luis? Wala si Mark. Thomas Jade? Okay. Nag-type si Mark. Thomas Jade, any problem? Any concerns?
None, sir.
Okay. Zachary?
None, sir.
Okay. Good. Thais? Limboy? Angel Casayas? Naka sa test? Mohatag pa ko nimo sa test ha. I-message lang ko please.
Okay.
Okay. Daniel Ricarte?
None, sir.
Okay. Ethan? Ethan Montoya? Wala? Okay. So, Kiara? Okay. So, kung wala, okay. So, God bless. Like sa quiz. And I'll be posting the vector perusal aron makabasa sad mo about that. Okay, before posting the lesson guides on vectors. Okay, so wala na ilaing concern. See you next meeting. And if you have some concerns like di mo ka human sa exam kay naputo lang internet, just message me. So far I'm not strict with the submission of those lesson guides. Just see to it na makasubmit mo within the quarter. Okay? So and also maka-catch up mo with the quiz. If you have some questions, don't hesitate to email me or message me through our module site. Okay, if wala na concern, goodbye everyone. Okay, God bless.
Bye, sir. Thank you,
Okay,
sir.
bye-bye.
Thank you, sir.
Okay, thank you.
Thank
Bye,
you,
sir.
sir.
Thank you, sir.
Okay, thank you and God bless.